Hello students, so we are back again with another topic from the resistance, because in the previous video we studied about resistance and we are going to talk more about it. We are going to talk more about it in this video as well. So let's start. I have taken 4 wires over here. The first one is wire AB. The second one is wire A-B-, which is of the same wire but only of a different length. So the length of A-B- is more than the length of AB. The third wire is A-B-, which is of the same material and the same length, but the only difference, as you can see, that the wire A-B- is of more thickness. It is having more thickness. So it is having a diameter more. So example, and when I take out the refill of this pen, let's say this is the wire AB and this is the wire A-B-. So as you can see, this is a thinner wire and this is a thicker wire. So this is the difference. It is the same length but it is of a different thickness. And previously this A-B- is of the same thickness but longer. So A-B- is longer, same thickness, but A-B- is the same length but more thickness. So we'll talk about this. Let's continue. So AB resistance, I need to find the value of this resistance. So I take this wire AB and then I put it in the Ohm's law experiment over here, conductor AB, and then I find the value of R. I find the value of R and then I remove it, and then I attach another wire A-B'. So in the same experiment AB, I attach wire A-B', and then I find the value of R, that is R'. So when I find this value, it is very amazing to see that the R' is more than R, which means that the second wire A-B' is resisting even more current. That means the current in the second wire will be less than before because it is having more resistance. So the current flowing in the second wire will be less than before. I repeat this statement. I connected first AB in the circuit, I find the value of R, and then in the second wire I connect A-B' in the same circuit, and then I find the value of resistance, which I name it R'. Now the value of R and R' will be different. This R' will be more than R because it is having longer length. Its value will be more than R. That means it is having more stopping power, and when it is having more stopping power, the current will be less. In the first case, the resistance is less, so it is having more current. So I am writing I is more than, for this I in, and for this it is I dash. So the current will be more than I dash because R dash is having more stopping power. Now in the third case, like I said, the thickness is more. Even though it is of the same length, but the thickness is more. So now when I connect this wire, I find that value of R double dash, this value of R double dash is even smaller than the original value R. That means what happens is this resistance has decreased. So when I use a thicker wire or a thicker conductor, at that time the resistance decreases, and when the resistance decreases, current increases. So I have the current I double dash. So now I write that the current I double dash is more than the current I. So because there is less resistance, I repeat, when the resistance is less, when the stopping power is less, then the current is more. If the resistance is more, then the current is less. So if the resistance is less, then the current is more, and if the resistance is more, then current is less. And in the last case, I have taken a wire AB again. Now it is not of the same material. Let's say this is the wire AB made up of a conductor, that is a steel or an aluminum or a copper wire. But this is not a conductor at all. Let's say that it is a plastic material. It is a plastic material. Let's say I have taken the refill, and when I connect it in the circuit, will it work? It will not work because it is not a good conductor. It is a bad conductor. So even though it is of the same length, same thickness, the current will not pass through this because the resistance also depends on the material used as well. Because the resistance also depends on the material used, and this quality or the material, the property of material is called resistivity. The property of the material is called resistivity. Up till now we were understanding resistance and it is a constant. Yes, I get that, but it is different for different materials. But let's say I have a copper wire which is of this much length, and I have again a copper wire of this much length. Obviously they both are copper wires. This is a copper wire and this is also a copper wire. They both are made up of copper. They both have same thickness. But the length is different. But they both are of the same material. So even though they are of different length, their resistance will be different. The resistance will be different. But the material is same, so the resistivity will remain same. Remember, resistance is a constant for a given conductor. Resistance is a constant for given conductor, and resistivity is a constant for a material. That means it doesn't matter if I take a thicker copper wire or a longer copper wire, the material's resistivity will remain same. And this resistivity can be given by this simple formula, that resistance R is equal to rho into L upon A. Like I said, resistance is constant, but it changes if the length changes, and it also changes if the thickness changes, which is given by area. Because the wire is of a circular shape, as you can see, the wire is of a circular shape, so it is given by area, and area of a circle is pi r square. We have studied it in standard 8th. The area of the circle is pi r square. So the resistance is constant, but for a material, for a single material. That means if the length changes, then resistance changes. If the area changes, its resistance changes, but the material will not change. So like we saw in this example in the previous video, that AB and A-B- are of the same material. They both are aluminium wires, but because their length is different, the resistance is different. And once again, AB and A-B-, these two were of the same material, but this is a bigger thickness and this is a larger thickness. It is having a larger diameter, and therefore this resistance changed. This was less resistance than the original wire AB, and therefore it was having more current, because less resistance means more current. So even though it is of the same material, the resistance changed, and this resistance depends on the material as well, as along with the length and the area. If the area increases, then the resistance decreases, like this. If the area increases, that means thickness increases, then the resistance decreases, and when the length increases, then the resistance also increases. Look, resistance is constant, but for this conductor only. If I change the length, then it becomes a different conductor, and it will remain constant for that conductor. I am not changing the words. The resistance is a constant, but for that conductor only. If I change the material, if I change the length, then it becomes a different resistance. So that different resistance will remain constant. this resistance and this resistance, they both are different, even though they are of the same material, same area, but they are having different length. So they both are different conductors, and therefore different conductors have different resistances. And for that we have a formula to find the resistance, that is given by this simple formula: resistance R is equal to rho into L upon A. You remember rho, we studied rho as the density in 9th standard. Yes, it is the same rho that was to find the density, but this time this rho is used for different purposes. So we are not forgetting that, but this is a different branch of science, so we are using rho for a different purpose. So resistance R is equal to rho into L upon A. This rho is resistivity. Remember, we taught that resistance is a constant for a conductor. So the resistance remains constant for a conductor, but this resistivity is a constant for a material. So let's say I have a copper wire of this much length and I have a copper wire of this much length. They both are copper wires, this one and that one as well. So I have two copper wires, but the material's resistivity will remain constant. But we know that if the length is different, then the resistance is different. But if we talk about the material, it is of the same material. Two copper wires, AB and A dash, B dash. So even though they both are of the different length, but they both are of the same material, and therefore their resistivity will remain constant. So what is resistivity? Resistivity can be defined as the property of the material. Resistivity is the property of material which resists the flow of charges. Resistance was the property of the conductor to resist the flow of charges, but resistivity is constant for a same material, whether it is of a different length or different thickness. It doesn't matter, but resistivity always remains constant for that material. So the copper wire, aluminum wire, steel wire and iron wire, they all will have different resistivity. The SI unit for resistivity is ohm meter. The SI unit of resistivity is ohm meter. We will talk about resistance even more in the next video.